spraying stuff into the atmosphere to decrease the number of clouds in the higher levels of the atmosphere, thinking that properly, as the clouds are reflecting that light. It's actually frightening. And it is a description of hundreds of thousands of airplane flights high in the atmosphere, in the stratosphere, laying down particles of a very specific kind of gas. It is sulfur dioxide, is what the proposal is, to put down into the upper atmosphere, thinking that the sulfur dioxide is going to reflect that sunlight. Do we need to intervene in a natural system? Can we do it? We have just enough technology to really mess things up. Welcome to In Focus, where I have the opportunity to take a deep dive into a topic, either something that you have asked me to take that dive into through correspondence with my office, or something that I've come across in research that I'm doing personally as I put these programs together. Tonight, I want to talk to you about a report, a congressionally mandated report that was released by the United States White House recently, June 30th. This is the year 2023. The report is exploring technologies that we have available to us today to block the light from the sun as it reaches the earth, in the belief that if we reduce the amount of light reaching the earth, that somehow we are going to help mitigate climate change. There are so many problems with this thinking, and I'm going to do my very best to sift through these with you. The report itself is about 44 pages long. It was mandated earlier in this administration. And I want to be clear, just because the report exists does not mean that everything in the report will be implemented. It tells us, however, that the thinking is in place, that the considerations are being made in terms of applying these technologies to change the course of climate on our planet. The thinking itself is based upon the assumption that somehow climate needs to be fixed, that Earth is broken, and furthermore, that we as humans are responsible for that. Now, many of you know I'm a degreed earth scientist, I'm a degreed geologist, so I'm going to speak to you from a geologic perspective. I'm going to share with you some geologic history. I'm going to do it from a scientific perspective, but not technical. I don't want it to be so technical it's meaningless. However, I want you to see, when I say the science, it means that the data is there that does not support the assumptions that many people are making about climate in general and about temperature specifically. Now, I find this report really interesting because for so much of our recent history, it's been all about greenhouse gases, all about CO2, demonizing CO2 and all the sources of CO2, blaming CO2 for. There are some reports out there that actually say CO2 is the cause of the climate change and that humans are responsible for the CO2 that's the cause of the climate change. None of that's true. But this is important because we are now moving into first a political season in the United States. And unfortunately, scientific information is going to become the foundation for political arguments. I don't like to get into the politics a lot, but this is one of those places where the science and the data are either being skewed or cherry-picked to support narratives and agendas that the larger picture simply does not support, the peer-reviewed science doesn't support. So we have done some of this. If you have been with me in any of these past presentations, you've seen portions of what I'm going to say to you. But what's interesting about this report is it now is not talking about the CO2, it's talking about the temperature of the Earth itself. It's talking about reducing the temperature of our planet through the belief that the sun is the only source of that temperature. One of the things that's being left out, and it's beyond the scope of what I can do here, is that there are processes that are happening not in the atmosphere above us, but underneath our feet. I have an entire presentation that I'm working on now, and I wanted to do a good job on it. That's why I'm not sharing it with you right now. But what I'll say to you is a lot of the the process that is driving the climate change is coming from under our feet. It is coming from dynamics within the Earth's mantle and the Earth's cores that are changing the Earth's crust, increasing things like volcanic activity, seismic activity, and literally warming the oceans, releasing more CO2 from the oceans into the atmosphere than we are producing through fossil food, the use of fossil fuels. Just to throw out a couple of numbers here, just to give you a sense for what I'm talking about. We now know that the oceans, some of you, I think, may not be familiar, that oceans hold gas and they hold CO2 among those gases. The colder the temperatures, the more CO2 can be held in the oceans. Now, what's interesting is the oceans are warming. They're not warming from the top down, they're warming from the bottom up, which means the atmosphere is not doing the warming. The statistics now are showing that the amount of carbon emitted through the oceans is about 330 gigatons per year, whereas human contribution is about 40 gigatons per year. And a large percentage of what we are emitting into the atmosphere is sequestered into the oceans and through the forests. Something like between 80 and 90% of what we are emitting in the natural cycle is the uptake of our CO2 emissions is part of that cycle. So even if these numbers are off a little bit, you're looking at the magnitudes over 330 gigatons versus 40 gigatons. Where's most of the CO2 coming from? It's not from us. So this is a fundamental flaw in the argument. Now, this report is not talking about CO2 because they're concerned about the temperature. And this has always been the issue. The CO2 is believed to be driving the increase in temperature. It may be contributing to some degree, but it certainly is not the cause. We are not the cause because these processes were happening long before humans, the first humans, emerged on the Earth. And we can see that in the geologic records. The way that the report is exploring reducing the sunlight is problematic. It's actually frightening. And it is a description of hundreds of thousands of airplane flights high in the atmosphere, in the stratosphere, laying down particulates, particles of a very specific kind of gas. It is sulfur dioxide, is what the proposal is to put down into the upper atmosphere, thinking that the sulfur dioxide is going to reflect that sunlight. We don't want to do that. And I'm going to say right now, and I'll be very clear, for me, I'm a big no on this. There's some things I believe that we just shouldn't mess with. The orbit of our planet is one of those. Some scientists want to change the orbit to reduce our relationship to the sun, to cut down on the sunlight. That's crazy. That is a crazy thing to even propose. Others now are proposing changing the atmosphere of our planet. And this is why I wanted to speak to a global audience, because whatever happens, this is an American proposed project. It's going to affect the entire planet. And I think it's something that we need to be aware of. The thinking underlying this proposal is something that we need to be aware of, because whether it happens through spraying the gas or whatever, a number of different ways I'm going to outline for you as I get into this presentation. It is the underlying thinking, in my opinion, the scientific arrogance that says we know enough that we can responsibly change the parameters of life on this planet in a healthy way. And what happens so often is that the science is very myopic. The science will zero in on creating one effect without recognizing how that one effect actually is interrelated with the rest of this living dynamic system that we have. And you'll see that as well. So what I want to do, let me get into the specifics of this presentation. Let me share with you what the study is saying specifically about sulfur dioxide in the gases, why it's a problem, what the past tells us about what's happening now. Are we experiencing the highest temperatures that we ever have? If you watch legacy media, the answer is yes. That's what everyone is being led to believe, but the data doesn't support that. And if the temperatures are higher, is it a problem? And if it's a problem, who is it a problem for? I think you might be surprised by some of the answers. So let me jump into this presentation, and I think you'll see what I mean by this. So as I mentioned, the report itself was released June 30th, 2023. This is the actual cover of the report, and I'll read the title. It's a very long title. It's titled Congressionally Mandated Research Plan and Initial Research Governance Framework Related to Solar Radiation Modification. That's a big title. I'm sure everyone is going to want a beautiful hardbound version of this report on your bedstand for light bedtime reading. It's a little wordy, it's a little complex. As I mentioned, it's about 44 pages long. The bottom line is that Congress mandated a study to modify solar radiation. And as I said, it was released on June 30th. So this is a copy of the cover of the report that, as I mentioned, was released on June 30th. And if you cannot read the title on your computer, I'll read this for you. It reads, Congressionally Mandated Research Plan and Initial Research Governance Framework Related to Solar Radiation Modification. So the bottom line, they're exploring ways to block natural sunlight from reaching the Earth in the belief that if they can reduce that sunlight, the temperatures on the planet are going to cool. They're not talking about some of the other implications like photosynthesis, for example. The plants of our planet need that light for photosynthesis to create the oxygen that you and I are breathing. That's a big factor right there. If you don't have the opportunity to read this report, now I have given you the link so you can do that. If for some reason you're not going to read, I'm just going to give you the bottom line. And I'll quote this. This is directly from the report. It says, the White House Office of Science and Technology Policy is coordinating a 5-year research plan to study ways of modifying the amount of sunlight that reaches the Earth in order to temporarily temper the effects of global warming. So this is interesting because in the past, we've been taught that the CO2 levels elevated are what's causing that warming by capturing the sunlight. Now they're going after it a different way, or in conjunction with, because they're still trying to reduce the CO2. And now they're saying if we can reduce the amount of sunlight, that's going to help as well. The report goes on to say, these are highlights from the beginning of the report. There are several kinds of sunlight reflection technology being considered, including stratospheric aerosol injection. That's what we're going to talk about, putting gas high into the atmosphere to reflect the light, marine cloud brightening, and cirrus cloud thinning. And I'll talk about both of those. Stratospheric aerosol injection involves spraying an aerosol like sulfur dioxide into the stratosphere, and because it has the potential to affect the entire globe, it often gets the most attention. Well, I would hope so, because it's going to affect every human on every continent in every nation, because climate doesn't know about those borders and boundaries. So if something like this is going to happen, first of all, I think it needs to have the support of our global population. It should never be allowed to be conducted through a single nation or even a group of nations that have gotten together without their constituency supporting this. And the next statement, the next bullet actually says this. It says, while arguments of moral hazard have handicapped the research efforts. So look at what it's saying. There are people that are concerned about this, and I'm glad that there are people concerned about it. They should be concerned. It's saying, while those concerns have slowed down the research, the idea is getting more urgent attention in the worsening climate crisis. Well, do we have a climate crisis? We are seeing rise in global temperature, and we are seeing a rise in CO2, and the effects that those things are having. There are a lot of natural disasters being attributed to these effects that are not actually the outcome of the climate and what's happening in the climate right now. So this is one of the illustrations in the report showing the different ways that are being considered to reduce the sunlight. Number one at the lower left is surface albedo enhancement. So albedo is the amount of light that's being reflected back into the atmosphere. And there are plans to do things as extreme. One of the plans is to spray tremendous amounts of snow on Antarctica, or the ice caps, for example, to reduce the amount of light being reflected by the ice back into the atmosphere, or growing crops with broader leaves that will reflect more light back into the atmosphere. That's surface albedo enhancement. Number two is increasing the reflectivity of clouds, marine clouds. Okay, I'm reading on my computer here and it's small print. The reflectivity of marine clouds. So they want to put stuff into the atmosphere to make the clouds brighter so that they will reflect more light before that light reaches the earth. Number three is what we're going to talk about here, is increasing the amount of stratospheric aerosols, and these are aerosols that they're talking about putting in. Number four is reflecting the light from space before it ever reaches the earth, using very large mirrors, for example, and mirror arrays. There's a whole report talking about that. And number five is increasing the amount of high altitude cirrus clouds. Decreasing the amount. So spraying stuff into the atmosphere to decrease the number of clouds in the higher levels of the atmosphere, thinking that properly as the clouds are reflecting that light. There's so many problems with this. I'm going to share with you the interconnectivity of all these things, but that is the issue. Can you reflect the light? Absolutely. At what cost? At what price? What functions now are being hurt? What systems of life are being hurt at the loss of that life? So let's talk about this. The proposal right now is to use sulfur dioxide particles. What is sulfur dioxide? It's a gas. It's made of sulfur and oxygen. And we know a little bit about sulfur dioxide. And the reason that sulfur dioxide has been chosen, one of the reasons, is because typically sulfur dioxide is one of the gases released in volcanic eruptions. And we know from past eruptions that the sulfur dioxide from the volcanoes does in fact stay into the atmosphere. The particulates linger in the atmosphere. They reduce the amount of light, and the temperatures on Earth do drop. Now, there are times in the geologic past where those temperatures have dropped. The light has been prevented from reaching the Earth for a period of years. And the temperatures have dropped to a point where extinction level events have happened in years past. And I'm not saying that's what would happen if this were done, but I am saying there's a history of the ability of sulfur dioxide to interfere with light reaching the Earth and to have a cooling effect on the Earth. One of the most recent, I believe, was 1991. It was I believe that was the year, Mount Pinatubo released about 15 million tons of sulfur dioxide into the stratosphere, and it cooled the Earth by anywhere from a half a degree to a full degree Celsius for a full year. So we know that worked. There are side effects to sulfur dioxide, and I want to talk about those. Some of them include that sulfur dioxide doesn't stay in the atmosphere forever. It is going to be mixed with other particles. It will eventually return to the Earth, and when it does, it's going to be acid rain. Now, some of the younger people watching this broadcast, it sounds scary. Even the word acid rain sounds frightening. But if you were not alive in the 1970s, you may have never heard this before. Acid rain was the big buzzword in the 70s, like CO2 is in the 2000s and in the 2019, 20, and 21, 22, 23s. Acid rain was a problem. It was the result of a lot of pollution in big cities, and that pollution was causing acid rain. The acid rain was harmful to ecological systems, as you'll see here in just a moment. And then all of a sudden you didn't hear about acid rain much anymore because we cleaned up a lot of the pollution. So it returns to the Earth as acid rain. That acid rain falls on the land. It lowers the pH of the soil. It on the land, when it rains, the runoff takes it into rivers and streams and lakes and oceans. And also, because this is a global proposition, that acid rain would be falling into the oceans as well, contributing to the acidification of the oceans that is already a problem right now. So it lowers the pH. When the pH is lowered, it becomes more acidic. That is a problem. It's harmful to forests. It is harmful to the food chain in the oceans. It kills the phytoplankton, which is at the base of the food chain. It also kills many forms of fish. It has historically all kinds of marine life. And as you begin killing massive amounts of marine life, there's a sequence. Larger forms of life feed on the smaller, smaller feed on the smaller, smaller feed on the smaller. The phytoplankton is among the foundation of that food chain. If we significantly deplete the population of the phytoplankton, that is going to impact everything the rest of the way up the food chain. That's just in the oceans. The soil erosion, and we've seen this, when the plants in the forests die off, the root system's no longer able to support that soil, and then the soil erosion that comes from heavy rains and the loss of living forests leaves them as kindling for forest fires. I mean, all of these things are harmful side effects to sulfur dioxide, as well as respiratory problems for humans, rashes, and allergic reactions to humans. All of these are very, very well documented. I want to show you something. This is fascinating. It's going to look like an excursion beyond the topic just for a moment. Then I'm going to use this to illustrate something. 2018, American scientists released a map of the human metabolic system. What this is, it shows how everything in the human body is connected to everything else. And if you cannot read this map, I don't want you to worry, because neither can anyone else. It is so complex. It is impossible. If you're going to try to copy this down while you're taking notes, you'd be better off just to take a picture of it, because it is so complex. Here is the human metabolic map. There it is right there. Now, why am I sharing this with you? This is a beautiful example in biology of what is happening now in the geology and the geophysics and the climatology of our planet. This map shows you why, when you ingest a pharmaceutical or anything, an herbal supplement, any food, anything you put into your body, it does not affect only one system in the body. For example, if you take an antihistamine for an allergy, yes, it can help with the allergic reaction. We also know it can cause drowsiness. It can make you sleepy, and that's why the label of the antihistamine says, do not drive or operate heavy machinery while you're taking this. It can make it difficult to urinate for some people. It can have allergic reactions for some people. It can interfere with other drugs or other herbal supplements that people are taking. So the point is that the antihistamine is not limited only to the system that affects the antihistamine. When you ingest anything, it affects everything to some degree in the body, because everything is connected. So I'm sharing this with you because this exact principle applies when you think about our planet. Reflecting the sun so that the light doesn't reach the earth. Yes, we can do that with the technology, but what else are we affecting? Well, excuse me, I just shared with you the metabolic map of a human. What I'm going to share with you now can be considered as the metabolic map for Earth, because Earth has many interrelated systems. The atmosphere is what we're talking about. So yeah, you're going to put sulfur dioxide in the atmosphere, but we have something called the hydrosphere that's linked to the atmosphere. This is the waters of our planet. Then we have something called the cryosphere that is linked to the atmosphere and the hydrosphere. And this is the ice, significant amounts of ice throughout history and continuing today on the planet, on the poles, in Greenland, Iceland, the North Pole and the South Pole, Antarctica. The biosphere is all of the life everywhere on the planet that's linked to both of those, and what's called the geosphere, or sometimes the lithosphere. This is the Earth, the surface of the Earth itself, the rocks and the soil of the Earth. So we live in this dynamic living system where everything is interrelated, and what we do in one system just like in the human metabolic map, the way it affects other systems, it's going to affect other systems in our world as well. And that's something that we have to keep in mind. So the sun blocking technologies that we're talking about, there was a Yale University report released in the year 2023, in July of 2023. And it said, if we were to implement these, it's not saying we are, and I don't want to frighten people into saying that this is happening. The fact that it's being considered, this is what would be involved. If we were to implement these technologies, it would involve 125 high-flying jets that are spraying in the stratosphere 60 degrees north of the equator, 60 degrees south, so that the particles can migrate into those polar regions. Now look at this. It says Earth would be cooled by 2 degrees Celsius or 3.6 degrees Fahrenheit. That is a big deal. That is a significant cooling. And I'm not sure that we want that cooling right now, because geologically, what I can say to you, and it's beyond the scope of what I can show you here, I will in a subsequent program, but what I'll say to you is that we are in a geologic process right now where, because of the dynamics under our feet, the dynamics in the mantle and the core of our planet are shifting, we are seeing an increase in volcanic activity. We're seeing more volcanoes, we're seeing strong volcanoes, and the potential of what are called super volcanoes releasing, we have no control over right now, releasing tremendous amounts of sulfur dioxide into the atmosphere. We know that it happens on a cyclic basis because we are in the cycle. The last time we saw this was about 12,500 years ago in a time called the Younger Dryas, and 12,500 years, 13,000 years before that, it happened as well. So we can expect increased volcanic activity, increased sulfur dioxide in the atmosphere, bringing the temperatures down. If we add to that through this technology and bring it down another 3.6 degrees Fahrenheit, we're going to be in trouble. And I'll show you on the geologic map. We don't want those kinds of temperatures on our planet right now. If we were to do this, to maintain, if we wanted to, if we even wanted to maintain this effect, it would require 175,000 of those high altitude jet flights a year just to maintain that. Well, think about what those jets are burning for fuel. The fossil fuels in those jets are contributing to the greenhouse gases that we're trying to eliminate, because we're being told that the greenhouse gases are causing the warming that the jets now are spraying to try to reduce. The logic in this, it makes no sense. It makes no sense whatsoever. So it begs the question, do we really need this? Do we need to intervene in a natural system? Can we do it? We have just enough technology to really mess things up. We have enough technology to understand how to reflect the light. The holistic nature of our planet and the interrelated nature and the long-term effects and the cycles that we are in that are not even acknowledged by most environmentalists are factors that complicate this whole conversation. Do we really need it? Well, it's all about perspective. And let me show you what I mean by that. Some of you have heard me talk about ice cores. As a geologist, we use ice cores to understand climate in the past. We did not begin taking direct measurements of things like CO2 until a time called the IGY, the International Geophysical Year, 1958. I remember this when I was a kid. It was a big deal. Everybody was talking about this. The International Geophysical Year is when we began taking consistent measurements using technology that could document these. Before that time, before we had that technology, we have to rely on other methods to tell us what's happened in the past. They're called proxies. And the ice cores are one of those methods. Every year, there's a new layer of ice deposited on the North and South Poles, Greenland, Iceland, Antarctica. And in those layers of ice are captured bubbles of the atmosphere at that time. They contain the carbon dioxide, they contain the oxygen, dust particles showing if there's volcanic eruptions, pollen grains showing the movement of of air masses, all kinds of things. I've talked about this extensively. I have spoken about this extensively in other programs, so I won't be redundant here. Those of you who are seeing this for the first time, I want to honor you so you have some idea of what we're talking about. The ice cores come from Greenland primarily and Antarctica, and they are kept in an ice library. And from this library, we can tell all kinds of stuff. We can tell what the ancient CO2 levels were, the ancient oxygen levels, the ancient temperatures, how strong was the sun, how strong was the magnetic field, and much more. The library looks like this. This is one of a number of ice core libraries. You check out a tube and examine the ice just the way you would check out a book from the library. Well, it's from these ice cores that we can begin to determine ancient records of the past and compare it to modern records. So let's take a look at some of the records that are being shown causing concern among people who are not informed about what this data is showing. Let's look at recent temperatures in terms of a little over 100 years, okay? Here we have from about 1858 until the year 2020, a record of the global average temperature. Now, if you look at this, it would be easy to interpret this as something that is a crisis, something that is concerning. Are the temperatures warmer now than they were in 1860? Yes, they are. Is that a problem? Is it anomalous? Is it concerning? Is it dangerous? Are these the highest temperatures that Earth has ever seen? Are they the highest levels of CO2 that Earth has ever seen? Well, the answer to the last two questions is no, we're not. And this is what I said, the reason I said that perspective is so important. If you look at only 100 years, which is nothing in geologic time, it looks like there's a problem. However, if you go back now and you look at millions of years, I'm just sharing this with you for perspective. What you see, this is on the right-hand side is today, on the left-hand side is 500 million years ago. And I don't want you to get lost in the details, but what you can see is in the past, Earth's temperatures have been much higher than they are today. We're actually on the low end. Even though we're a little higher than we were 100 years ago, our temperatures are still relatively low. Let's take a look at this now. Instead of hundreds of millions of years, let's look at it in terms of thousands of years. So now I want to be really clear on what you're seeing here. This graph can be misleading if you're reading it incorrectly. Here's what I mean by that. This is not it's not meant to be a continuous graph read from left to right. There are places right there, right there, right there, right there. These are places where the data for scale has been put together, but it's not one continuous record. So I want to be really clear about that. Okay, but we can see from this, the last image we saw, this was in millions of years. I want to now take a look at a few thousand years. So if you look on the right-hand side, look at the right-hand side of the graph, humans, anatomically modern humans, us, we showed up on Earth only about 200,000 years ago, where I just placed that line on the graph. That's where the first modern humans emerged 200,000 years ago. This is a graph of temperatures. The temperatures were relatively low. There was a spike not long after we showed up, and then we went into the Ice Age. Much of human existence was occurring during the time of the Ice Age. And when we came out of the Ice Age began right around 20,000 years BP, before present. And when we came out of the Ice Age, right around about approximately 12,000 years ago, what you see is the temperature stabilized, and they've been pretty much stable up until right now, till the present day. And you can see that on the right-hand side of your screen. Now, what you also see is a couple of red dots where temperatures are being projected into the future. Here's a problem. Those projections are coming from computer models. The computer models are tremendous. Well, first of all, there's not one model. There are many models. The many models are tremendously controversial because they are inaccurate. And let me share with you how inaccurate they are. A model is supposed to predict what is happening on a climatological level based on a number of parameters, based on cloud cover and precipitation and humidity and geographic location, all these kinds of things. So if a model is accurate, we should be able to take the data from a time that has already happened, like a month ago, because we know with certainty what the data is. Plug that into the models, and the models should tell us what it is that happened a month ago. That's not what has happening. The models are so flawed, they are so skewed. The term is, in climatological circles and geophysical circles, is the models are running hot. They are over calculating Earth temperatures, and that's why they have not been accurate. That's why we have not seen the temperatures that the models predicted, 10 years ago, 20 years ago, because the models are broken. They're not good for long-term predictions. So when you see predictions like this on the map up to 2050, there's so many things. I'm doing an entire presentation on this, and I don't want to be redundant here with what that presentation is going to be. What I want to say is there's so many parameters that are either poorly understood or not even taken into consideration, that the models cannot be taken seriously for long-term projections. The models are really good to tell us about interrelationships. The models are very good for that. Models are not good. They are flawed when it comes to long-term projections. So what I want you to see from this is that we are relatively stable in temperature. We're actually a little on the low side compared to where temperatures have been in the past. And CO2 that we are being told is driving the temperature is not always correlated with the temperature. Now, there's a whole lot going on in this graph. So let me just highlight. The blue is the average global temperature. The black is the atmospheric CO2 from the past. We, present time, are on the far right-hand side. And what you can see in our recent past is the CO2 levels have been low, but the temperatures have been high. If the CO2 is driving the temperatures to be high and the CO2 is low, that means something else is going on, and it is. There are other factors that are driving Earth's temperature. One of those, as I mentioned, is beneath our feet. There are geophysical processes in the mantle warming the oceans, melting the ice from underneath, that are releasing the CO2 after the temperatures begin to rise. Temperatures rise first, and then the CO2 follows. But you also see right around 150,000 years ago, the temperature dropped and the CO2 was high. So we cannot say that temperature and CO2 is always correlated. And that's what I want you to see from this. Now, there are three geologic time periods that I'm going to call your attention to in the orange: Triassic, Jurassic, and Cretaceous. Probably familiar with Jurassic because of the movie Jurassic Park. Triassic, Jurassic, Cretaceous. I want to show you what was happening on Earth during those three periods of time in terms of temperature and in terms of CO2 and in terms of life. So let's take a look at this. The Triassic CO2 levels were way higher than they are right now. Right now, they're about 417 parts per million. During the Triassic, they were as high as 2,000 parts per million. The temperatures were a lot warmer, kind of like being in Dubai. Those of you in Dubai, you know what I'm talking about. 122 to 140 degrees Fahrenheit. Now that's warm, but it does not prevent life from existing. And when we say that the CO2 today is higher than it's ever been, temperatures are higher than they've ever been on Earth, these statistics, this data tells you that simply is not true. Higher than they've been. The temperatures are higher since we've been keeping temperatures. Yeah, since the IGY, 1958, 1962. The first records of temperature, 1868, is when the National Weather Service started taking direct measurements of temperature. So even going back to 1868, what we see is this is not the highest that the temperatures have ever been. Now, Jurassic, this is when the movie Jurassic Park, all the dinosaurs were living, a lot of them during this time. CO2 levels were lower. They were down now to 1,000 parts per million. Temperatures were actually pretty nice. Between 59 Fahrenheit was the average global temperature. That's a nice temperature. Average global temperature. It takes into account the poles and the tropics, everything in between. Between 80.6 Fahrenheit and 59 Fahrenheit, that was the high and those were the lows. So that's a nice temperature range. Cretaceous, during the Cretaceous period, CO2 levels went back up, and a lot of that is attributed to volcanic activity as well as some geophysical activity, warming the oceans, releasing CO2 back into the atmosphere again. Temperatures were still nice, averaging from 82 Fahrenheit to highs to lows of 52 Fahrenheit. These are the times during the Jurassic and the Cretaceous, it was a greening of the earth. Those high CO2 levels are food for plants, and the forests thrived. There was abundant life, new forms of life in the oceans and in the seas. Now, the oceans were a little warmer, and some forms of life did not survive. Other forms thrive in this. The point is that we're not living the highest levels of CO2 Earth has ever seen. We're not living the highest temperatures, and when we've had high CO2 and high temperatures, Earth has thrived. The ice was reduced, forests grew, life thrived, and there were no multi-story buildings that were built, 30 feet away from the edge of the beach. So during these times, the ice melted, the sea levels rose. If you were living close to a beach, that would be a problem. And that's part of what the problem is today. It's not a problem for the Earth. It's a problem for the way we have chosen to live upon the earth, building on the floodplains, building next to the oceans during this time. There was another presentation that I did earlier in the year, and some of you have not seen it, so I'm going to share this little piece with you. An exercise that I did in January of this year, January of 2023. I read through all of the projections from the United Nations, all the projections from the World Economic Forum, of where they believe we should be in terms of temperature and CO2. What are the targets for the CO2 that they're trying to drive us toward? So right now, when this last readings were put together, CO2 was at 414 parts per million. Right now, 2023, I believe it's about 417 parts per million is where it is, okay? Now, in 2010, that number was 390. And I'm using that number because the UN is using this number. They want to reduce the CO2 levels 45% from 2010. What that means, 45% reduction of 390 CO2 target would be 214.5 parts per million. This is the goal of United Nations World Economic Forum. This is a really, really low level of CO2 on planet Earth. It's dangerously low. We don't want to drop below about 180 parts per million. Historically, when that happens, Earth is not healthy. Forests die, life forms die off, and temperatures drop dramatically. So 214 parts per million is low. This is the target they say that we want. What does that mean? Well, here's a peer-reviewed article from this was called Nature Communications 2019. The title of the article, Low CO2 Levels of the Entire Pleistocene Epoch. What does that mean? The Pleistocene is a period of geologic time. Interestingly, it's when we appeared on Earth. 200,000 years ago is during the Pleistocene. And what we now know is that for the entire time that the Pleistocene existed, carbon dioxide averaged about 250 parts per million. What else was happening during that time? Well, let me show you. Here's a little geologic map to give you some idea of what we're talking about. So you can see on the left are huge periods of time called eons, divided into smaller periods called era, into smaller periods called periods, and into more specific periods called epochs. So we are living in the Holocene epoch right now. Before that was the Pleistocene, and the Pleistocene is when we emerged 200,000 years ago. Pleistocene conditions. What was Earth like during the Pleistocene? Well, the average CO2, the average temperature, the average ice, and life. I want to share with you what life was like when the first of our kind emerged on the planet. The average CO2, as we said, was 250 parts per million. Today it's 417. The average temperature was 46 degrees Fahrenheit globally. This is a pretty cool temperature. Today, we're over 10 degrees warmer. We're 11 degrees warmer, 57 degrees Fahrenheit. The ice, because of the lower temperatures, there was way more ice, which means the sea levels were lower. The water was locked up in the ice. During the Pleistocene, about 8% of the Earth in total was covered in ice, and a quarter of the land, 25% of the continents, was covered in ice. Today, only about 3% of the Earth is covered in ice, only about 11% of the land. What was life like? Well, let me show you. During the Pleistocene, in those cooler temperatures, with all of that ice and with those very low levels of CO2, forests died off. They were covered by the ice. They couldn't survive in the cold temperatures. There was the extinction of large species of life, including large mammals. This is when the woolly mammoths died out, and saber-toothed tigers died out, and some sloths died out. 32 species were extinct in 2,000 years, is what we know of large animals. This isn't counting the microflora, the microfauna, and things like that. So today, we have more CO2 and the Earth is a little warmer. And what is it like? Well, according to NASA, this is a NASA study. This isn't a Gregg comment. You know, it's not my perception. This is NASA telling us that Earth right now is greener than it was 20 years ago, and Earth is in a greening cycle due to the elevation of the CO2. So when we look at this, if we were to achieve those metrics put forth by the UN and the World Economic Forum, we would drive Earth back into Pleistocene conditions of lower temperatures, more ice, dying forests because of the lack of CO2, lower levels of CO2, again, 250 parts per million CO2, and extinction level events for many forms of life. So we have to ask, why would the recommendations be out there to do that? Why are we being asked to push our world back into a time when life was a struggle? It's interesting to me that we appeared during that time. We appeared in a difficult time, and obviously we survived. We adapted and we survived. Why the effort to push us back? Why block the sunlight to cool the planet? Why drop the CO2 levels that the forests need, that the plants need to create the oxygen that we're breathing, presumably to drop those temperatures? Who benefits? The answer to that question is a whole conversation unto itself. I can tell you right now, it's not us. We are not the ones that benefit. So when it comes to sun blocking technology, we have to ask the same question: who benefits from this? As a scientist, I have worked in the scientific community and academia since the 1970s, early 1970s, in the corporations since the late 70s. And I can tell you that there is often an arrogance in the scientific community when it comes to solving problems, and an ego that says we know all the answers and we understand how everything works. There are also really good scientists out there pushing back on these technologies, and they're writing letters to the White House. They're writing letters to their publishing in scientific journals saying, not so fast. We don't understand these connections. We don't understand the implications. We're playing with something that can have dangerous repercussions. And once we drive, if we were to be successful, driving these parameters back, lowering the temperature of the Earth, lowering those CO2 levels by depleting the energy from the sun, the light from the sun reaching the Earth, it's not like a switch that you can turn off and on. There are feedback mechanisms and feedback loops that are set into motion, and it would be a very, very long time before we could correct a mistake. So who benefits from this? That's a question that we all need to ask ourselves. When these kinds of reports are coming out, they wouldn't be coming out if these technologies were not being seriously considered and if they had not already pilot tested these technologies in small locations. You know this has already happened. So I think it's important to be aware of what the proposals are, of what the thinking is underlying those proposals. It's also important to be aware of what the data is showing us and how the data doesn't support the fundamental assumptions that are driving this technology. It has become political. It has become financial. Businesses, academics, and political processes are all involved in making these decisions. So what does this mean for us? Well, first of all, it's our money paying for the technology, and that money is being spent by our elected officials. How can you voice your opinion? You can call directly your elected official and say no to sun blocking technologies. If they ask for details as to why, feel free to refer them to any of these videos. I am certain that most political people have not seen these because they are not technical, number one. They have not been made aware of what we're talking about, number two. And they are following a narrative that has supported them in their life path. I know scientists working in this industry, they're good people, and they have been fed false information and skewed information through the skewing of data in algorithms when we do our searches, through censorship on scientific papers, and in the public domain. This is a consequence of that kind of censorship. When we do not allow the discussion and the discourse, we run the risk of making mistakes, and in this case, big mistakes, global consequences affecting every human on the face of the earth that we cannot reverse in a heartbeat. It would take years and years and years to reverse these kinds of technologies if they were allowed to go forward. So I wanted to share these with you so that you have some sense. It's going to be in the media, and these conversations are now going to be driving a political narrative as we roll into an election season here in the United States and possibly even other countries. I don't want to make anyone wrong, and that's not why I'm sharing this. I don't want to argue. That's not why I'm sharing this. How can we solve the problems if we're not honest about the problems? The problems that we're facing with climate change, we've known about since the 1960s. The climate rhythms told us that we could expect these changes. Are we adding to it? Probably. Can we stop the CO2 emissions if we really wanted to? Yes. We've had the technologies to do it for over 70 years. That's another conversation. The powers that be were serious. We would unleash those technologies to elevate the living standards of every human on the face of the earth in the absence of fossil fuels. And I believe you will see that happen in the near future for a number of reasons. So a lot of this data, a lot of this conversation is being driven by false assumptions based upon obsolete science that's not supported by the data. I've shared a little bit of that with you. And I think what I really want you to sense from this, as I talk to people on the street and in our programs, there's a sense of guilt that somehow the earth is broken and we have broken it. And I want you to see from the geologic perspective, from the charts, the graphs, and the records, that we have polluted the earth, definitely. And we have polluted the ecosystems, definitely. But when it comes to temperature and CO2, we're nowhere near the records that we've had in the past. And Earth thrived in the presence of higher levels of CO2 and warmer temperatures. It's our civilization, as we have built it, that would have the problems. It's 30 and 40-story high rises built 10 feet from the water that would suffer as those sea levels rise. It's the building of single-family dwellings on floodplains that were made illegal back in the 50s and 60s and now have been given a pass. So we're building places that don't allow for the dynamic nature of climate that we live in. Earth is a dynamic system. Climate is dynamic. We have been led to believe it is static, and that when it changes, something is wrong. So this is what I wanted to say to you in this presentation. I hope I'm helping to maybe have a little bit better sense for where we are in the cycles and what the report means, the thinking underlying blocking the light of the sun, and from my perspective, why I believe it would be a mistake to implement this technology. Thank you so much for sharing part of your day or your evening with me, and I look forward to our next.